Hello my precious friends, I really hope that you are doing great. Welcome to today's class. It is our fourth and last lesson on the topic indices. So we are looking at further examples involving indices, and this is our example number 13, which is also a past cases question done in the year 2009, paper 1, question number 5. So it reads, without using log tables or calculator, evaluate 64 to the power of negative a half multiplied by 27,000 to the power of 2 over 3, then over 2 to the power of negative 4 times 3 power 0, then times 5 to the power of 2. So it is a question worth 4 marks. So we are going to break down the given values in terms of their factors. So let me start with 27,000. So you want to break down 27,000 so that I find its common factors. So I'll start with 3. So 27,000 divided by 3, you are going to get 9,000. You'll get 9,000. Then 9,000 divided by 3, you are going to get 3,000. So this will give us 3,000. Then 3,000 divided by 3, you are going to get 1,000. Then 1,000 divided by 10, you are going to get 100. 100 divided by 10, you are going to get 10. Then 10 divided by 10, you are going to get 1. So that means 27,000 can be written as 3 to the power of 3, then multiplied by 10 to the power of 3. Similarly, we look at the factors of 64. So by 2, 32, then by 2, 16, then by 2, 8, then we have by 2, we are going to get 4, then by 2 we get 2, then by 2 we get 1. So 64 is 2 power 1, 2, 3, 4, 5, 6. So this is the same as saying 2 to the power of 6. So if I substitute these values, I'm going to have, so 64 is 2 power 6, so this will be 2 to the power of 6. Then on the 64 I had a half on the power, so this will be multiplied by negative a half. Then I multiply with 27,000 is the same as 3 power 3, then multiplied by 10 power 3. So this is 3 to the power of 3 multiplied by 10 to the power of 3. Then the 27,000, this one was to power 2 over 3. Then I divide by 2 to the power of negative 4, then multiplied by, remember a number to the power of 0 is always 1. So 3 power 0 is the same as saying 1. Then multiplied by 5 to the power of 2. So this will be, of course 2 will go here, 1, 2 into 6, 3 times. 3 multiplied by negative 1, you'll get negative 3. So we'll have 2 to the power of negative 3, then multiplied by, this is the same as saying 3 power 3, then the 2 over 3 will multiply each of the powers. Then we also multiplied by 10 power 3, then this will also multiply its power by 2 over 3. Then the whole thing divided by 2 to the power of negative 4, then multiplied by 1, then multiplied by 5 to the power of 2. So of course 3 and 3 will cancel out, 3 and 3 will also cancel out. Then from there I'm going to take the remaining values. So I have 2 to the power of negative 3, then multiplied by 3 to the power of 2, so 3 to the power of 2, then multiplied by 10 to the power of 2, so 10 power 2, then divided by 2 to the power of negative 4, then I multiply with, remember 1 times a number is the same number, so I'm going to pick times 5 to the power of 2. Now let's look at the values, whether we have numbers with similar bases. So you can see these two have similar bases, so I can take 2 to power of negative 4 to the numerator such that the power will be negated. So the negative of negative 4 will give you positive 4. So let me take these numbers to the this number to the numerator. So I'll have 2 to the power of negative 3, then multiplied by 2 to the power of positive 4. So if this one goes to the numerator, we negate the power, so the power will change to positive 4. Then times, we had 3 to the power of 2, then times 10 squared, then the whole thing divided by 5 to the power of 2. So whenever you multiply, you are supposed to add the powers. So this will give us, let me create some space here to finish up the working. So if you take 2 to the power of -3, then you multiply with 2 to the power of 4, you are simply going to add those powers. So this will be equal to 2 to the power of -3, then we add 4, because we are multiplying similar bases, so we add the powers, then multiplied by 3 to the power of 2, then multiplied by 10 squared, then the whole thing divided by 5 to the power of 2. Now -3 plus 4 will give you +1, so that means we are going to have 2 to the power of +1, then we multiply with 3 squared, then we multiply with 10 squared, then divided by 5 to the power of 2. So this will be 2 times 3 squared will give you 9, then 10 squared will give you 100, then divided by 5 squared will give you 25. Now 25 into 25 1, 25 into 100 4 times. So if you take 100 divided by 25, you are going to get 4 times. So we are going to remain with 2 multiplied by 9, then multiplied by 4. So if you take 2 times 9 times 4, you are going to get your final answer as 72. So this will be equal to 72 as the final answer. Then we look at our example number 14, which is also a past case question done in 2010 paper 1, question number 8. So it reads, without using mathematical tables or calculator, evaluate 27 to the power of 2 over 3 times 81 over 16, then to the power of -1/4. So this is the same as saying we are going to find the factors of the numbers that we have. So let me start with 81. So the factors of 81 will be, of course, 3. So 3 into 81, 27 times. Then 3 into 27, 9. Then 3 into 9, that is 3. Then 3 into 3, 1. So 81 is actually 3 to the power of 1, 2, 3, 4. So this is 3 to the power of 4. We know that 27 will be 3 to the power of 3. Then of course we also have 16. So 16, its factors are 2. So 2 into 16, 8. 2 into 8, 4. 2 into 4, 2 into 4. So this is 2 into 16, 8. 2 into 8, 4. 2 into 4, 2 times. Then 2 into 2, 1 time. So 16 is the same as saying 2 to the power of 1, 2, 3, 4. 2 to the power of 4. So if I substitute these values, I'm going to have, so the 27 is 3 power 3. So this will be 3 to the power of 3. Then on the power, I had 2 over 3. So times 2 over 3. Then multiplied by, into bracket, 81 is 3 to the power of 4. So this is 3 to the power of 4. Then divided by 16 is also 2 to the power of 4. Then the whole thing, of course, was to the power of -1/4. So this is the same as saying, of course, 3 and 3 will cancel here. So I remain with 3 to the power of 2, then multiplied by, so this quarter is going to multiply each of these powers in the bracket. So this is the same as saying 3 to the power of 4, then multiplied by -1/4, then divided by 2 to the power of 4, again multiplied by -1/4. So the -1/4 has to affect the numbers, the powers within the bracket. So 4 and 4 will cancel out. 4 and 4 will also cancel out. So we remain with 3 to the power of 2 multiplied by 3 to the power of -1, then divided by 2 to the power of -1. So this will give us, so you can see we are multiplying, then the bases are the same, so we'll simply add the powers. So this will be 3 to the power of 2. We add the powers, 2 plus negative 1, then the whole thing is divided by 2 power negative 1. So this will be equal to 3 to the power of positive 1. That is 2 plus and minus will give you minus. So 2 minus 1, you will get 1, then over 2 to the power of negative 1. So this is the same as saying 3 to the power of 1, then multiplied by this one. I can take it to the numerator, so the power will be negated so that it becomes a positive 1. Using the law that whenever you have 1 over a to the power of n is the same as saying a to the power of negative n. So this will be 3 power 1 is just 3, then 2 power 1 is also 2. So the final answer will actually be equal to 6 as our final answer. Then our example number 15 is also a past cases question done in 2012 paper 1, question number 5. It reads, given that 9 to the power of 2y times 2 power x is equal to 72, find the values of x and y. So in this case we are going to find the factors of 72. So 72, let me start with 2. So 72 divided by 2, you are going to get 36. Then 2 into 36, you are going to get 18. Then 2 into 18, you are going to get 9. Then of course 3 into 9, you are going to get 3. Then 3 into 3, you are going to get 1. So this one means 72 is the same as saying 2 to the power of 3, then multiplied by 3 to the power of 2. 3 to the power of 2. So this is going to give us 9 to the power of 2y, then multiplied by 2 to the power of x is equals to 72. So 72 is 2 to the power of 3, then multiplied by 3 to the power of 2. So we are simply going to express this one in terms of base 3. So we know that 9 is the same as saying 3 squared. So this is 3 squared times the 2y that was already on the power, then multiplied by 2 to the power of x is equals to 2 power 3, then multiplied by 3 to the power of 2. So this will give us 3 to the power of 4y, then multiplied by 2 to the power of x is equals to 2 to the power of 3, then multiplied by 3 to the power of 2. Then we are simply going to equate the numbers having similar bases. So this one simply means that either 3 to the power of 4y is equivalent to 3 power 2, which simply translates to 4y is equals to 2. Therefore the value of y will be equal to 2 over 4, which of course will give us a half. Or this one also means that the numbers having to base 2, this one also means 2 to the power of x is equivalent to 2 to the power of 3. So this one means that x will be equal to positive 3 as your final answer. Then we look at our example number 16, which is also a past case question done in 2014 paper 1, question number 6. So we are told simplify 243 to the power of negative 2 over 5 times 125 power 2 over 3, then divided by 9 to the power of negative 3 over 2. So I'm going to start by looking at the factors of 243. So of course I'll start with 3. So if I take 243, then I divide by 3, I'm going to get 81. So this will be equal to 81. Then by 3, 27. By 3, 9. By 3, 3. Then by 3, 1. So 243 is simply 3 to the power of 1, 2, 3, 4, 5. So 3 to the power of 5. Similarly, I also check the factors of 125. So 125. So I'll start with 3. 3 won't go there. So I'm going to start with actually 5. Let me start with 5. 3 won't go into 125. So I'll start with 5. So if you take 125 divided by 5, 125 divided by 5, you are going to get 25. So this goes here 25 times, then 5 into 25 5 times, then 5 into 5 1. So that means 125 is the same as saying 5 to the power of 3. Then of course we know that 9 is 3 to the power of 2. So on substituting, 243 is 3 to the power of 5. So this will be 3 to the power of 5. Then on the power I had negative 2 over 5. Then I multiply with 125 is 5 power 3. So this is 5 to the power of 3. Then I had 2 over 3. So times 2 over 3. Then the whole thing divided by 9, of course, is 3 to the power of 2. Then multiplied by what was on the power, negative 3 over 2. So 5 and 5 will cancel out. 3 and 3 will cancel out. 2 and 2 will cancel out. So I remain with 3 to the power of negative 2 multiplied by 5 to the power of 2. Then divided by 3 to the power of negative 3. So this is going to give me, let me take this one to the numerator, so it will be 3 to the power of negative 2 multiplied by 3 to the power of 3. So when we take this one to the numerator, we negate the power such that if it was a negative, it becomes a positive. If it was a positive, it will become a negative. Then multiplied by 5 to the power of 2. So the bases are the same. So this is 3 to the power of negative 2. Then I add 3. When you multiply, you add the powers. Then times 5 to the power of 2. So this will be 3 to the power of 1. Negative 2 plus 3, you get 1, multiplied by 5 to the power of 2. So this is 3 multiplied by 5 squared is 25. So if you take 3, you multiply it by 25, you are going to get 75 as your answer. So that will give us 75. Then we also look at our example number 17, which reads that simplify. So the example reads that simplify 25 to the power of 3 over 4 times 0.9 to the power of 2 times 2 power 2 divided by 5 to the power of 5 over 2 times 3 power 3 in the form A over B, where A and B are integers. This is a past case equation done in 1989, paper 2, question number 4. Then it's worth 2 marks. So we know that 25 is the same as saying 5 to the power of 2. So this is 5 power 2. 25 is 5 to the power of 2. So this is 5. So 5 to the power of 2. Then we multiply with 3 over 4. So times 3 over 4, that is on the power. Then multiplied by 0.9 squared. 0.9 is the same as saying 9 over 10. So this is 9 over 10. Then the whole thing is actually squared. Then multiplied by 2 to the power of 2. Then the whole thing divided by 5 to the power of 5 over 2. Then times 3 to the power of 3. So 2 here, 1, 2 into 4, 2 times. So this will be, I'm going to get 5 to the power of, so of course it will remain 3 over 2. So to the power of 3 over 2. Then I multiply with 9 is the same as saying 3 to the power of 2. So this is 3 power 2, then over 10. Then everything is squared. Then multiplied by 2 to the power of 2. Then divided by 5 to the power of 5 over 2. That is 5 over 2. Then multiplied by 3 to the power of 3. So this will be equal to, so I'm going to combine now. I'm going to take 5 to the numerator, so that I get 5 to the power of 3 over 2. Then I multiply with 5 to the power of negative 5 over 2. So when this one goes to the numerator, we negate the power. Then multiplied by, so 3 squared times 2, this will give us 3 to the power of 4. 2 by 2 will give me 4. Then 10 squared, of course, will be 100. 10 squared is 100. Then times 2 to the power of 2. Then on the denominator, I've left there 3 to the power of 3. I can as well take 3 to the power of 3 to the numerator, so that I'll simply negate the power. So this will give us 3 to the power of negative 3. So times 3 to the power of negative 3. So these are like terms. So this is 5 to the power of So this is 3 over 2. When you multiply, you add the power. So plus negative 5 over 2. This was a negative. Then multiplied by, so I have a 3 to the power of 4. But again, I also have another 3 here, which is to the power of negative 3. So when you multiply, you add the powers. So I'm going to add these two, the power of this one and this, since they are to the same base. Then of course times, I still have a 2 power 2 here. Then of course this was over 100. So this will give me 5 to the power of. Now if I take 3 over 2, then plus minus 5 over 2, I'm going to get negative 1. So this will be 5 to the power of negative 1. Then multiplied by 4 plus minus 3, you will get 1. So this will be 3 power 1, then over 100. Then multiplied by 2 squared, you are simply going to get 4. Then 5 power negative 1 is the same as saying 1 over 5. So this is equal to, remember, if you have a to the power of negative n is the same as 1 over a to the power of n. That's why this one is the same as saying 1 over 5 to the power of 1. I've just taken it to the denominator. So then times of course 3 power 1 over 100, then multiplied by 4. So this one simply means we are having 1 over 5, then we are multiplying with 3 over 100, then multiplied by 4. So if you compute this on your calculator, you are going to get 1 over 5 multiplied by 3 over 100, then times 4. You are going to get your answer as 3 over 125. So this is equal to 3 over 125. 3 over 125. Remember, you are told to leave your answer in terms of a over b. So this is the form of a over b, or in form of fraction. If you are asked to hence state the values of a and b, the value of a will be 3, then the value of b will be 125. So this is the form a over b. So this was our last lesson on indices. So that means that next time we'll be looking at a different form 2 topic. Thank you very much for accompanying me until the end of this particular lesson and this particular topic. Until next time, this is Kind Tuition Academy. Thank you very much.